Hi guys, today we're going to be talking about simple harmonic motion. And simple harmonic motion is abbreviated SHM. So if you see that, that's what that is. Simple harmonic motion is back and forth motion with no damping. Damping means that something is slowing it down. There's some kind of force, whether it be gravity or friction or something, some kind of force that's slowing it down. A simple pendulum. I have the simple pendulum here. It is a string, or is a weightless string, with a weighted mass, or just a mass on the end. We call that mass on the end, we call it a bob. And so the way a pendulum works is you pull it back, maybe I'll pull it back 10 degrees, and I set it in motion. And what I have on here right now is 100 grams. So I have 100 grams going back and forth from 10 degrees this way to 10 degrees that way. And if there is no damping, it's just never going to stop. And maybe you've seen some of these before in museums where they have this huge pendulum and it's going back and forth, and maybe it's drawing something in the sand, or it's going back and forth on this rose compass showing the direction. In any case, that's what we have going on. Is a simple pendulum is a weightless string with a mass called a bob on the end. An oscillation is back and forth motion. That's what that word means. If it's oscillating, it's moving back and forth. And so this right here, this is a pendulum, and it is oscillating back and forth. One period is what we're going to be focusing on. The period is the time it takes to go back and forth. So from wherever you start from that point back to where it started. So if you timed it from here to here. And so that would be one period or one oscillation. The question at the bottom is what we're going to be focusing on. The question is, what would affect the period? So as this is swinging here, what are some things that we could do to affect the period? How could we change the time that it takes to go back and forth? Well, one thing is, maybe you're considering, well, what if we change the mass? So this was 100 grams. What if I go up to 200 grams? And what if I stick with my 10 degrees to 10 degrees, but now it's at 200 grams? And now what if I timed it going from here to here? And would that be shorter or faster? I don't know. Or would it not be changed? Or maybe if I took a smaller mass, this one is 20 grams. So if I took a smaller mass and put it on here, and I go from 10 to 10, is that going to be going faster or slower? Right now it's spinning like crazy because that other mass had stretched out the string. But again, you would just want to time it from here to here and see if that time was shorter or longer than the other one. So that's another one hypothesis. Maybe the mass would change the period, the time. Let's think of another way to change it. Can you think of a couple ways? What if we changed the degree? I'm going to go back to the 200 because it had a little bit more mass to it, so it had a little bit more flow. If I go back to the 200, or excuse me, the 100, this is the 100. If I go back to the 100 gram, and instead of going from 10 degrees, what if I went all the way up to 20? And what if I timed this from 20 all the way back to 20? Would that change the time, the period that it takes? I don't know. And on the way this one is set up, I could change it in increments of 1 degree if I wanted to. That'd be pretty hard to read specifically, but you could go like from 5 to 5 and measure that. You could go from 10 to 10 and measure that. You could go from 20 to 20, etc. So you could do several trials of each one, and you're testing to see, does the different degree, does that change the time that it takes? So far we've said, what about the mass? What about the degree? There's one other thing we could change. What if we change the length of the string? So I have preset this where I've tied some knots into it because it has to stick in just the way this one works. I have to stick it in there, but you could really change it to any possible length. So if I did that, I'm going to go back to 10 and 10. Remember, that's what we started with, was 10 and 10, and I have my 100 degree. So if I go from 10 to 10 on my 100 degree, does changing the length of the string change the period? So that's something to consider. And of course, like I said, I've tied several knots in here, so we could go even shorter, and we could see, does this shorter one, is that going to change if I go from 10 to 10 and I time it, will that change it? So those are the three things that we're going to investigate of, does it change the period? Is the mass, the degree, and the length of the string, do any of those change the period? And if they do, how? So that's what we're looking for, is what is that relationship there. Finally, one that a lot of people think of is force. Like if I took this and I gave it some force, would that change the period? That's something to think about, and it's certainly something that we could delve into. The only problem is I don't have a way to measure that force right now. I would have to come up with a way, how could I measure that, and see if, because then could you do, like a different, how are you measuring how much that's hard to measure. So we're not going to go there, although a lot of people probably think that in their heads. We're just going to take those three, the mass, the length, and the angle. And that's what we're going to do in the lab that's following this.